Hi all, this is my video number 3 for differential equation. So in this video I'll talk on sturm system. Yeah, so what is the sturm system? So we consider that system Ly ddx px y prime minus plus qx y equal to minus lambda rx y, right? And subject to the boundary condition, or you can also write this as you can bring that to the left side. You can write that as ddx px y prime plus, if you bring it to the left, you have qx plus lambda rx y that equal to 0. Just the same thing. Alright, subject to the boundary condition, we have alpha ya plus beta y prime a that equal to 0, and then gamma y b plus delta y prime b that equal to 0. Okay, so let's call that system. Let's put it star, equation number star, where alpha squared plus beta squared different than 0, and gamma squared plus delta squared, this is also different than 0, and we have p and r are positive, px rx is positive on AB, and q and r are continuous on AB, and p differentiable on AB. Okay, so this system, those star is called the sturm level system. Sturm level system. Okay, so obviously that y equal to 0 is the solution of that of star. Yeah, y equal to 0 is a solution to that system. Yeah, it's a trivial solution. Now the eigenfunction for that problem will be twice differentiable, because it needs to satisfy those equations. Yeah, and we look at the definition. We say the eigenvalue problem, the star, yeah, eigenvalue problem, which is star, is said to be self-adjoint if integrate from a to b VLU minus U LV dx, this is 0. Yeah, for all U V in C in AB. Okay, this means that u and v are twice differentiable and continuous. And we have another definition. I have given you this definition in the previous video. Two functions, we say y1, y2 are orthogonal with respect to wave function. R on AB if integrate from A to B are yj dx, all this function of x, yeah, these are rx, yix, yjx, this equal to 0 if I different than j, and not equal to 0 if I equal to j. And we say it's autonomous. We say orthonormal if when I equal to j, the value of the integral give you value 1. So that we call it as a orthonormal. Orthonormal if y1, y2 are orthonormal if we integrate a to b r when I equal to j, so yi squared dx that equal to 1. And for this case, I've given the example for that. Okay, now we have the orthonormal, we have the sturm louville problem. Okay, now if you have a general second order differential equation, we can always convert to the sturm louville equation. Yeah, how to do that? Yeah, to convert a general second order homogeneous differential equation, to sturm louville equation. If we consider the a second order differential equation, a general second order differential equation, yeah, so consider the general second order differential equation, let's say in the form of a2x y double prime x plus a1x y prime x plus a naught xyx plus lambda rho x y x that equal to 0. I call this as a double star. Alright, and we know that for the sturm louville equation, we have this form. We have px y prime prime plus qx y plus lambda rho x or rx y x just equal to 0. Now we want to convert this general second order differential equation into the sturm louville types. Now how to do that? So in this case we need to find what P is. If we can find what P is, then we can just plug in there So this P related to that A2. So we can just plug in there. So then we can write this double star equation into that sturm type. Yeah. So you need to find P such that we have for that P prime y, yeah, Py prime. So Py prime, this is just Py double prime plus P prime y prime. Okay, so if we compare this part here, okay, with this equation, so we can see that from there we can see that this is equal to just A2x, A2 y double prime plus A1 y prime. Okay, from there, so we can see that P equal to A2 and P prime equal to A1. Yeah, so we have P equal to A2 and P prime equal to A1. So if I differentiate this, I got P prime equal to A2 prime and P prime equal to A1. So which means from here we have A2 prime, this is equal to A1. Alright, this is not always the case. Yeah, in general, this is not always the case. Not always true. Not always true. Now, so how to overcome this problem? To make it true. Yeah. So now if if we let nu, let's say nu, be the integrating factor, then if you multiply by double star, yeah, and multiply by double star, multiply by those double star, so what we get? So we will get nu A2 y double prime plus nu A1 y prime plus nu A0 y plus nu lambda rho y that equal to 0. Okay, so let's I call this as a triple star. That's so difficult, so many stars here. Okay, now, so what we need now, that nu A2 prime, which is we have nu A2 prime, this is equal to, must equal to that nu A1. Why do we do this? Because we want to write in that form. Okay, so you can see that part, this Q, so that Q we can obtain from that. Okay, so we have those things. Now, if we set P as a nu A2, then we have P prime is nu A1. Alright, P prime is nu A1. that. So P is A2, that. So we have new is new A1, yeah. So this is equal to that P, that new, so P A1 over A2, right? So just substitute those mu into that, so you got that P A1 A2. Now from here you can separate the variable. We have P prime over P, this is equal to A1 over A2. So to solve this, definitely just we need to integrate this with respect to the variable, differentiate that. So this will give you ln Px. On the right side you have integrate A1 over A2 dx. Yeah, you can take the exponent to the equation, so you have Px, this equal to, so we need some constant, E integrate A1 over A2 dx. Okay, now if you take C equal to 1, yeah, we take C equal to 1, C equal to 1, and nu as a P over A2, then we have nu x, this is equal to 1 over A2x E integrate A1 over A2 dx. So if we substitute this into double star, yeah, substitute this into that double star, the equation that I've just multiplied by nu there, then you can write substitute nu into double star or triple star, triple star. So we can write those as a P y prime prime plus qy plus lambda y ry that equal to 0, where P is equal to nu A2, Q equal to nu A0, and R is equal to nu rho. So the main point here to convert the general to the second order differential equation into the sturm equation, that we need to multiply with the integrating factor, multiply through those, then you can write those general second order differential equation into the sturm equation. Now let me give you example how to do this. Example, let's say we have a second order differential equation, 3x squared y double prime plus 4x y prime plus 6y plus lambda y that equal to 0. Okay, so I call this just another star. Yeah. This star is not the general one. This is for this particular case. Now we want to write this equation in the form of sturm-louville equation, which is that. Okay. So in this case, if you compare with the general second order differential equation, we have a2 is equal to 3x squared. Yeah, a1 4x, and you can find what integrating factor nu is given as 1 over 3x squared e integrate a1 over a2, so we have 4x over 3x squared dx. Okay, and then of course you can evaluate those things. So you have 1 over 3x squared e integrate those, and 4 over 3 you can take it out, so that 1 over x dx, that gives you ln x, e ln x cancel out, 4 over 3 becomes power. So we have this is x 4 over 3 over 3x squared. Of course you can write this as a 1 over 3x 2 over 3. Now we multiply nu, this mu, into the that star. So multiply mu to those star. So what we have, x 4 over 3 y prime, so y double prime, 4 over 3 for double prime, plus 4 over 3 x 1 over 3 y prime plus 2x over 3. So just substitute there everything. You got that? Y plus lambda 3x minus 1 y, that equal to 0. And hence from there you can easily write this as a x 4 over 3 y prime plus the rest is just the same as it is, plus lambda 3x minus 1 y equal to 0. Okay, so this is the sturm-louville equation. You know, from the general second order differential equation, we find the integrating factor, multiply through that, and then we can find the sturm-louville equation. Okay. So with that, I introduce you the what is the sturm-louville equation. Also, I have defined what is a self-joint eigenvalue problem. What is the orthogonal of two function, and also I give you the how can we convert from a general second order differential equation into the sturm-louville equation. I think I stop here for this video. Thank you.